as well. Ayun. Now, I'd like to call on once again Engineer Marilu Tallador to present our third and last speaker.
Good afternoon once again. Thank you, Ms. Anika. Our third speaker is both a civil engineer and a registered master plumber. In fact, he ranked 19th and first places in the PRC licensure examinations of these questions, respectively. He has actively engaged in the field of engineering as a private practitioner as well as academic during the early part of his career. He is the Director for Engineering and Technology in RV Architecture, Engineering and Technology. I should say I'm one of his proud mentors at Western Institute of Technology, Iloilo City. Ladies and gentlemen, our third speaker for this event to share his knowledge on the topic estimating automation using Excel VBA macro programming. Let us all welcome Engineer Felemuel D. Bullos, Jr.
Right, good afternoon, everyone. To my fellow Ilonggo engineers, maayong hapon. Am I clear? My audio is clear? Yes? Hopefully it is. Do you have a thumbs up? Yes, thank you for that. Let me share my screen also. Okay. Can somebody please allow me to share my screen? Host disabled participant. Okay, so sa liwat, maayong hapon, Ilonggo engineers. So my topic for today is all about estimating automations using Excel VBA macro programming. Okay, so we will not be talking about millions of pesos or dollars in acquiring the software because you will learn how to make the software itself. Okay, so this will be absolutely free for everyone. Okay, so thank you very much, Ma'am Tallador, Ma'am Malot, for the wonderful introduction. I'm going to introduce myself once again, although the introduction is quite glamorous. So I am Felemuel Bullos. I am a civil engineer. I am a registered master plumber. I'm likewise a project management professional, PMP from PMI. I am also an ASEAN engineer. I am also a certified materials engineer of DPWH. And not to mention, I also came from, just came back actually from Saudi Arabia. My previous company was SASIC Engineering. I worked as a project director there at Saudi Arabia for a private engineering firm. Okay, so currently I am connected with RV Architecture, Engineering and Technology. I am a co-founder and director at the same time of the company and the principal consultant as well. There you have my contact information. If you want to contact me, you are free. Okay, so let's have the main topic. Estimating automations using Excel VBA macro. This is quite very long slides, approximately more than 60 slides. So probably I'll be again having some overtime. I will just have to make this as fast as I can, as simple as I can. So when we say estimating automations using VBA macro programming, we are going to learn the programming itself. Okay, so probably not everyone is quite familiar with the programming, although the requirement for this topic is everybody must have learned or know already how to estimate, and everybody is using Excel as a tool in estimating. Okay, so the main objective, how can I draw this? Sorry. So the main objective of this is to promote awareness to civil engineers on the importance of programming know-how to solve simple to complex engineering calculations and automate repetitive tasks. Okay, so take note the term, automate repetitive tasks with the aid of Excel, VBA macro programming. And specifically, we are going to learn how to program estimating. Okay, estimates. We must be using, again, Excel to provide knowledge on how to automate the estimating tasks using Excel, VBA macro programming. For our outline, we are going to have some introduction. I'm not going to go deeply into the VBA macro programming itself. I actually revised my slides in order for us to consume our 2 hours time as fast as we could and as efficient as we can. So we have the introduction, and we're going to relate this VBA macro programming into the applications, the field of applications in the civil engineering. We're going to have the macro programming basics, and at the same time, we're going to have sample estimating automation also using VBA macro. Okay, so again, we are going to develop a mini program. Okay. The previous speaker shared to us very informative and really very important nowadays. The current trends in the construction industry, especially in the planning and design industry, using BIM or Building Information Management. When you're using Building Information Management, you are no longer required to do estimates actually, because every information is already in there in the program itself, in the software itself. And the software, I suppose, is already generating estimates for you. May material take-off na. But then, we have to invest a lot of money in order for us to acquire, and we need to develop our skills and the skills of our manpower in order for us to utilize efficiently those softwares. Now, in this case, we are going to what do you call that? We are going to train ourselves for immediate solution for the problems that we are encountering daily as civil engineers. Okay. Let me introduce first what is Excel macro. In simple term, the Excel macro is an action or set of actions that you can record, give a name, save, and run as many times as possible. Okay, you can record the actions. Okay, so if you have a certain lines of codes that you can run repeatedly, instead of, say, for example, 10 processes in doing the estimate, you can only click a button, a single click in the button, you will generate the estimate itself. Why not? Okay, so you can multiply the effort or the rate of output actually 10 times if you just have one instead of 10 processes. Okay, so you can multiply yourself 10 times actually, or more than that. Macros help you to save time on repetitive tasks involved in data and manipulation of data reports that are required to be done frequently. only. Okay, so please take note that you only make program if you are doing this repeatedly. Okay, for those actions that you seldom use, you don't need to go into programming. Eh, pwede mo man siya obrahon, or you can do it actually manually if it is not just if you seldom use that same process. But if you are using the process on a daily basis, maybe you can program once and then you can run it as many as you can, maybe hundreds of times, thousands of times in your life as a civil engineer. Okay, that's programming. What is VBA? So we're talking about VBA macro. VBA is simply the language that we are using in coding our macro. Okay, so we will be using the VBA or Visual Basic for Applications in Excel as a tool in developing our program. Okay, so it's basically a language and the environment where you can code, do your coding. VBA is used to write macros to automate simple to complex tasks in Excel. Other software actually are also having some macro. Even this PowerPoint, there is macro. Even Word, there is macro. But macro for personally is applicable or very efficient to be used in Excel because we are doing the calculations usually in Excel. Okay. What are the civil engineering applications? Okay. So first and foremost, you can do it. You can have the Excel macro programming in quantity surveying estimation. That is what we're going to discuss today. You can have it also in your structural calculations. When I had my company before I joined the company in Saudi Arabia, I had my company here in Iloilo City. I usually brag to my co-civil engineers who are coming to me to have structural design. So I am bragging that, okay, just sit down, relax, have some coffee, and after you finish your coffee, you will have your structural calculations. That is because I automate the structural calculations and, of course, the estimates in such a way that I can produce it as fast as I can. While you're sitting, just wait, relax, and you will have it after maybe an hour. You can have it also in your project planning. That is if you're using Excel in your project planning. Surveying, calculations of levels and bearings. You can have it in your bar bending schedules. You can have it in transportation engineering. You can have it also in your hydrology and of course a lot more. Whenever you use Excel and you are using that same Excel sheet a lot of times in your career, you must be doing some macro programming so that you'll be able to automate and simplify every process that you are doing on a daily basis. Okay? Basta nagagamit ka sa Excel, you can do it in a very simple and efficient manner. Okay. What are the pain points? In doing manual procedure, when we say manual procedure, we just make use of some format of Excel, and I'm not talking about manual that is written, handwritten. We are using software, of course, but the most common software that we're using in estimating is Excel. I hope everybody will agree on this. So during using manual procedure in Excel, it's very time consuming. I know everybody will agree to this. Very time consuming because you will be doing your calculations manually. Even if you are good at Excel, it takes a lot of effort And of course, if you are running a company and you're having somebody doing the estimate for you, it will be manpower incentive. You will be spending a lot of money in just doing the estimating itself. Okay, so wait for maybe 5 days before the estimate can be finished, whereas you can finish it actually in one sitting. So in short, costly ang manual procedure. Okay, there is always a risk of human error. When you're doing your calculation, where you're doing your typing manually in Excel, there is always a risk of human error, manual procedure. And of course, the result will be inaccurate. And as a result, there is a quality issue. Okay, quality issue. And of course, not only that, if your estimate is wrong, okay, somebody from site will purchase the materials that you have estimated, and then boom, something is very wrong and something will happen. Okay, it will involve money again. Either your estimate will be too short or your estimate will be too big, excessive, then that's not good. Okay. What is the solution? We're going to have Excel VBA macro. Why? You can automate repetitive tasks. Okay. So say if you are doing some estimate for a footing, you just have to encode the dimensions of the footing and the number of bars, and then you will have the output automatically using a single click of button. That is what we call as automation. Okay, you don't need to do something very special. You don't need to have some calculations even in Excel or in your calculator. You just have to click encode the input data and then click a button. That means that you will have less time in developing your estimate, less effort, of course, less manpower. Okay. If you have the Excel VBA macro as a program that you develop yourself, you have to check and counter check first before you use it. Okay. So you develop only once, only once, and then do or use it multiple times. Okay, hundreds or thousands of times. So think about that. I'll be doing this. I'll be using this 1,000 times more. It has to be accurate before I use it. Okay, so because you check and counter check before using, you will have a very precise calculation, and of course, you will have accurate result. Okay. Before I proceed, let me show you the output for today's lecture. This is what I developed, and actually this is, I prepared the slides out of this output. I have here several sheets: BOM detail, BOM summary, estimate, material, sizes, and specs. These sheets are actually required in developing our program later. Okay. The most automation is here in the estimates. So I had here a sample of the automation for the footing. Okay. So let me have it. So if you notice, the data here are being cleared or deleted when I click this. So say for example, I have, this is isolated footing input. These are just inputs, but actually the calculations are within already the programming. So say for example, I have 15 number of footings. Isolated footing, the dimension is say 1,500 by 1,500. The thickness is say 350, 16 mm diameter. You can of course have some drop down and select. Say for example, we have 11 pieces. So you will notice also that something is changing when I change some inputs, because usually if it is square footing, the number of pieces along X and the number of pieces along Y is already the same. You can also select the strength of concrete and the rebars, grade say grade 40, and factor of safety for concrete. So I just add say 0.5% and 1% for the rebar, and then I'll click and boom, you'll notice that you have already the estimate including the costing. Okay. Again, say for example I have some more footings. So say I have 10 pieces of 1,300 by 1,300, 350 thickness, 10 pieces both ways, 16 mm, 3,000 psi also, grade 40 also, the same factor. I'm going to have estimate append and the values of that latest input will be added in my estimate. Okay, so that is how fast we can develop the estimate. That is how fast. Imagine if you are developing this in manual manner. So all you have to do is to have this copied, copy, and then go to your BOM summary, BOM detail rather. Go to, this is the format that you are actually acquiring or using. So substructure, I'm going to paste it here. And yes, you have it. Some automations could be, say for example, in BUM summary, there is no data yet. I'm going to delete all this. But I'm not going to delete the data from here because these are the divisions in our BUM detail. See that? 1, 2, 3, so on and so forth. Okay. So the estimate that I am having here in BUM detail is up to section 21. So I just have to click, okay, the auto-generate summary, check, and then I will have the summary of all these things. Yes? Is there a problem?
Hello, Engineer Bullos. Sorry po to interrupt you. But the shared screen, sir, nga gagwa sa amon nga screen is different from what you're presenting now. Siguro wala na lain nga tab, sir, ang na-share screen nimo.
Oh, okay, okay. So do I need to stop share and then share another? Yes, no?
Yes, sir. Thank you.
Okay. Share screen. Sorry for that. Are you viewing an Excel form?
Yun.
Excel?
Yes, sir.
Okay, okay.
Thank you.
Thank you. So I was talking about the automation here. This is the Excel format that we are going to make use in developing our program later. Okay, so we have sheet here like BOM detail. This is, I suppose, the original Excel sheet that you are utilizing. Okay, you are utilizing in your estimate. But I added the summary. This summary is actually also the format that we are utilizing. The additional here is the estimate wherein which we are going to automate. Most of the automations is in here. So just like, for example, footing. Okay, so I'm going to click here a link or button, footing, and see how fast we can do the estimate of the isolated footing. Okay, so say for example, granting that we have 15 number of units for the footing with a dimension of 1,800 by 1,800, say thickness is 400, and we have 16 mm diameter. You can of course select say 11 pieces, Then 11 pieces also along the Y direction. We have concrete strength. You can select that. You have also the grade of steel that you can select, and the factor of safety in your estimating. Let's have 5% for the concrete and 10% additional for the rebar. Okay. So I just have to click this button, estimate override. Yan. And then automatically you have the estimate of the materials for your isolated footing with the data that you have input. Okay. So say we have an additional of 20 footings of different dimension. Say we had footing 1, we had, for example, for 2. So we have 20 pieces of 1,500 by 1,500. The depth is 400, 16 mm diameter. We have 8 pieces only. 16 mm diameter along y-axis is 8 pieces also. 3,000 psi, the same, with the rebar factor the same. We can have append. Okay, so observe what happens in here when we append. Append. So we just actually added the values of second footing sets in the quantity and of course in the cost. Okay, so that is how fast we can have our process of estimating by just doing the inputs if you have already the calculations and the programs within. Yes. We can have also some automations like in the BOM summary. I'm going to delete all the data. Delete. And just like a magic, take note that from BOM detail, you have several sections. From section 1 up to the last section there is 21. Air conditioning. Okay, from 1 to 21. The BOM summary, we're going to encode from 1 to 21 here also. And then just click a single button, auto-generate summary. And you will have all the information extracted from the BOM detail. Okay? So that is what we call as automation. Imagine if you don't have that automation, you will have to encode this manually, or you can have it copy and paste from one sheet to another individually. Copy and paste here, the material cost, paste also, labor cost, paste also, or you can have also the formula equals material. Labor cost equals BOM detail, labor cost. That is the procedure if you know Excel. Okay? But then, if you have the automation, imagine that you're going to do it one by one. Huh? If you have the automation, you just press a button and automatically everything will be generated and you have the total construction cost. That's what we call automation. Okay. Now, let me stop sharing this also. I'm going to go back to my main slides. Okay. So that was the output that we are expected of for this particular lesson. Basics. You can only use VBA if you save your Excel in XLSM or macro-enabled workbook. Okay, so you just have to save that, save as to Excel macro-enabled workbook. You know how to save as. Okay. Again, I'm presuming that you already know Excel. Okay, and you know also estimates at the same time. We only automate the process. You automate. Okay, so again, you have to save as in XLSM file or macro-enabled Excel file. For your easy manipulation of the macro, you're going to activate the developer tab. Okay, this is an additional tab. Usually this is disabled. Ang developer tab is disabled. So you go to Excel options and then you check this developer. Okay, you are now to be a developer of Excel. Okay, so we're going to have it checked. When you check it, you will notice that there is an additional tab. This one, the developer tab for your Excel. Okay, so these are the menu or tools that you can use in your development of your program. Very important here are the first one, which is the Visual Basic, wherein if you click this, you will be able to open the Visual Basic or VBA environment. Okay, there is another window, the VBA environment, where we are going to develop our program. Yeah. Others are not usually being used because everything is being manipulated or encoded in the Visual Basic program. You can have also macros. That macros, there is a submenu that you will be able to have a direct link on the macros that you have developed or the programs that you have developed. So this is for the developer tab. When you again click this Visual Basic, okay, it will divert you to another screen, which is this one, the Microsoft Visual Basic for Application Environment, okay, VBA editor. There are three major windows that basically shown. The Project Explorer is very important. This is where we're going to have our major component of our project. Properties window. Every time that you click a project in here or a program or a module or form, you can always change the properties of that component of the program from the properties window. Okay, from the properties window. And at the right side, the big screen is what we call a code window. This is where we are encoding our program, the codes. Again, I'm not going to go deeply into programming, but you will be able, ibalikan nyo lang ang screen, just go back to the screen, to the slides whenever you have time. And I'm going to share also the output so that you'll be able to see the codes by yourself. Okay, the output Excel program that we are talking about in here. You will have it also. You will have the copy. Okay, so prerequisite, we have to get the worksheets ready. I have shown you earlier the worksheets that we will be using. Okay, so granting that you have already a worksheet by your own, your format, your company format, your personal format. This is the personal format that you're having. Okay, so get it ready. The summary worksheet. Usually, we are doing this also in separate sheets format that you are using in your estimating. So the summary, the additional sheet that we are going to have is the estimate, because what we are going to do is to automate our estimating using this sheet. Okay, so we're going to develop a program that will write the quantities, the description, specifications, quantity, unit, and the costing of your material from this sheet. And then we are going to copy this and paste in your BOM detail. That's the procedure. Just copy and paste. Okay, so what's important here is that we can generate the materials takeoff in this sheet, and we just have to copy it in the original sheet, which is the BOM detail. That is our target. Okay, the materials worksheet. Some programming may not need this, but for me, in order for us to automate better, we can have the database of our material. Okay, because this is where we're going to get the costing. Okay, so if you have the database, you will have the material cost and the approximate labor cost. You can always change this whenever you paste. And of course, this material database can be updated regularly based on the actual cost of the material and the current cost of the material. Okay, so maybe you have to change to update the costing on a monthly basis or a quarterly basis. That's up to you. So you will have the list of all your materials from here. Then size worksheet. The size worksheet is where we're going to generate our form. Okay, so our form will be we'll get it from this material worksheet, our size worksheet. So say for example, the size for your rebars, 25, 20, 16, 12, 10, 9, 8, so on and so forth. You can have also the sizes of your say anchor bolts from here. You can have also the sizes of your W sections, steel sections from here. The input is limitless, okay? But you have to guess, okay? You can always modify what I'm talking about here, but for me, I'm going to have it the sizes from here so that if you have noticed, there is a drop down in your form, in the form that I presented earlier in Excel. That form got the information from this sheet, okay? The size of rebars. Specs worksheet. If you notice also, we had a drop down of the concrete, 5,000 PSA, 4,500, 4,000, so on and so forth. And the grades of rebar, that drop down was actually taken from this sheet also. So take note of that. That is specs sheet. Okay. So I think everything is ready now. BM detail, BM summary, estimate, material, size, and specs. I might be doing this lecture too fast, but then you can always go back to these slides. Okay. You have to finish this on time. Okay. We're going to create now the VBA macro program. First and foremost, we're going to insert module. Okay. So all you have to do in your VBA for applications environment, you can have right click from the project, and then there is a submenu that will appear after you right click and you insert module. Okay, so we're going to insert module. The module is some sort of a sheet that we can code our macro. Okay, we're going to code our macro and call it from the Excel sheet from there. So after we insert the module, there is, you can notice that there is module 1. Okay? You can always rename this module. Pwede ma-rename from the properties. Okay? So there is a blank sheet that will appear in here in the code window, wherein which you are going to encode your macro. Okay? So in this particular example, we are going to create macro. We name it as clear estimate. Okay? In our Excel sheet, we're going to clear the estimate in the estimate sheet. Okay, very basic. We're going to have a very basic focus in this. A macro, a program shall start with the sub. Okay, and then name it whatever you like. But take note that when you name, you will be able to identify the name later, because we are going to assign this to a certain button later on. So I name it clear estimate, because this macro will clear the estimate section of our Excel sheet. Okay, so declare. We are going to declare first the workbook. Okay, so we declare. Declaration starts with the DIN. standard for declaration. We are going to declare the workbook as WB. So declare WB, deem WB as workbook, and then we're going to set that WB for this workbook. Don't you worry if you don't really understand or comprehend this topic. You can always copy and paste my program, my codes. I'm going to share the Excel file to you. We declare also WS estimate as worksheet because we're going to use this worksheet, okay? The worksheet, which is WB. WB is set for this workbook. That sheets, we call this sheet estimate. If you remember, there is an estimate sheet that we created. Okay, this is it, the estimate. And we are going to have a code WS__ estimate, which is our worksheet. The range from A10 to L25, we are going to clear the contents. So within that sheet, if you are really familiar with Excel, the range from A10 to L25, we are going to clear the contents. Okay? So what it is doing, did I unshare? Yes. I'm going to share another one. Okay. This is actually ranging from B11, B10 to 25, this one. So that macro will clear this, just like you press this, select all this, and then press delete. That's the procedure. That's it. Press delete, or you can have clear, okay? Where am I? A minute. I have to go back to my slides. Slide. Okay. So this clear estimate, once again, clear this section from, what was that? A10 to L25. Okay. So from your Excel sheet, from A10 up to L25, it will clear this section. That is what it is doing. Okay. Now, we are going to create a shortcut button. So if you notice, I created a clear, actually this is just a text box. Okay. Then after I created the text box, the clear text box, I right click, then assign macro. Okay, right click, then there will have the drop down menu to assign the macro. After you press assign macro, you will see your clear estimate macro. Okay, from this workbook or the current workbook that you are working with, clear estimate, and then you press OK, and then you will have this button to activate your macro. Okay, so you only have to press this. You don't have to go anywhere to clear the section. It will activate the macro. It will run the macro. Okay. Next, inserting the user form. In programming or in automation, you always need to have a user form wherein which you are going to encode the values. Okay, there is a form that you are going to encode the values that you are needing in order for you to generate some information. So this is what we call in here as user form. Okay, so again, right click anywhere from this section, insert user form. So when you insert the user form, okay, there will have a blank form that will appear. Okay, from this blank form, we are going to create some objects. Okay, we are going to change the caption. Okay, so user form name, caption, and other properties. So take note that I have already changed the isolated footing from here. The user form, I changed to the name isolated footing, and then I changed the caption to isolated footing so that it will appear here as isolated footing in the top section of your form. Okay, so that's it. Then we're going to insert some labels. So you will need to have the toolbox. The button to show the toolbox is this. And this is your toolbox from here. You press this A, which is the label, and then you drag it here. So there will have name label 1. That is how you insert a label. Now, we are going to have to evaluate what are the necessary inputs that we are going to have automated. What are the inputs that we are going to be needing in order for us to calculate the quantities that we are needing. So for this particular example, we have an isolated footing. Isolated footing with length L along Y direction, width B along X direction, and the thickness Z along the Z direction. Okay? We'll have also the lean concrete. Okay? The column location. But the necessary information that we are needing are okay, math bars. So this is the detail. What are the information that we are going to be needing? Number of units. So say for example, you have 15 pieces of this wall footing number 1, column footing rather, column footing number 1. So number of units would be 15. That's it. Huh? The width along X. So the width along X is this. The length along Y is the dimension along Y axis. It could either be in meters or mm. The depth or the thickness along Z. That is, and of course, we have to estimate also the rebars, diameter and quantity of rebars along X direction. So these are number and quantity and diameter along X direction. And of course, the diameter and quantity of rebars along Y direction. We need also to have concrete for the specifications of your concrete. Every concrete strength will have a corresponding cost. Okay? The stronger it is, of course, the more costly. Rebars grade, grade 33, grade 40, grade 60. Estimating factor for concrete and estimating factor for rebars. So these are the information that we need. So after evaluating all this, we're going to have it in our user form. So you'll notice after inserting a label, we have number of units, width along X in mm, length along Y in mm, depth along Z in mm, rebars. There will have a input text box later in here that will have the diameter and number of pieces along X, diameter and number of pieces along Y, concrete strength, rebar grade, concrete factor, and rebar factor. Okay. So after that, you already have, this is just a copy and paste. Just like any other software, this is also another software that we can do Control C and Control V. We can always drag and drop to duplicate and move. We are going to insert next text box. The text box, this one, you can insert it from here. Okay, you see that AAB, that is a text box button. So click that and then drag that within our user form and create a box in here. You can, of course, change all the properties of this text box. What's important is we are going to rename. Okay? You can have it colored. You can have some effects on this. But in our case here, this is just but simple. We're utilizing the default options, the default appearance. Okay. So after inserting the text box, we're going to copy and paste also all those text box and position it to where it belongs. Okay. So I have also added to a yellow text box here because I always need calculator in estimating. So aside from all those necessary inputs, I also need to have an input for my basic calculator that can do addition, subtraction, multiplication, division, and there will have an answer in the next text box here. So that I will no longer look for a calculator somewhere. I will be able to utilize the same form for my calculation, for my basic calculation. Say for example, if you have a grid of 3 by 5 column footing, so 3 times 5, you will have an output of 15 from here. Okay, or any other calculation that you may be needing. So all your text box are already created and with the defined names. Okay, what's important in programming here is the name. You'll notice that the name here for the first text box is N, because this is for the quantity or number of units of your column footing. Okay. Next is we're going to add combo box. A combo box is somehow a text box, but it will generate a drop-down menu. Okay. Combo box coming from the toolbox. Okay. From toolbox here, this is the combo box. If you can see my cursor. Okay. So just click that, drag that here, and then adjust the width. The width is approximately your text will be fitting or will fit in this combo box. Okay. So again, duplicate that combo box, copy and paste to other locations. So you will have in this particular example 1, 2, 3, 4 combo boxes. The rebars, diameter of rebars along X, diameter of rebars along Y, the concrete strength, and rebars grade. Okay. So I think we have one more step to go, which is adding buttons. Okay. Adding buttons. After you complete later all the information, fill up all the information, you click the button and it will generate values. It will generate information into your Excel sheet. Okay, so we create button. This is very important also, the button. Just like text box and combo box here, we can also have it copy and paste. Okay, copy and paste and then rename. Yeah, okay, so we have how many buttons here? 1, 2, 3, 4. We have the estimate append button, estimate overwrite button, calculate button, and clear button. The calculate and clear will have the calculation for our mini calculator. And estimate append and estimate overwrite will generate information. If you say estimate overwrite, it will clear all the information in your Excel sheet, in your estimate sheet, if you say generate, clear and generate, when we say estimate append, the values of the new estimate will be added to the previous estimate. Okay, append. So in previous, maybe in your footing 1, you have 3 cubic meters of concrete. In your footing 2, you have 5 cubic meters of concrete. The result for estimate append will be 3 plus 5. Will be equal to 8 cubic meters. Yan. Okay. So we now have a complete form. Okay. So this is the view of our complete form. We are going to name all these inputs and buttons. Okay. So number of units will be n. Width along x will be x. Width along y will be y. The depth along z value, z also. These names are very important in programming. Dia x for diameter of bars along x. Num x for number of bars along x. Dia y for rebars along y. Num y for rebars, for number of rebars along y. Concrete strength, spec concrete, because this will be used as variables. Names will be used as variables. Rebars grade. Factor for concrete is factor concrete. Factors for rebar is factor rebar. So just try to have some names that you can remember, but take note that there will have no duplicate. Okay? And the software will not allow you also to duplicate. That you can remember and you can comprehend whenever you do the programming. Okay? Calc and ans. Calc for the calculator, answer for the answer. Okay? Loading drop-down menu for combo box and user form activate. Drop-down menu. When we when this user form, we call it isolated footing user form, will appear or will be shown, there must have some sort of automatic action that will happen on that form. And especially when you are using the combo boxes. The combo box shall provide you with a drop-down menu. Okay? So that drop-down menu shall be coded. Okay? So this is the code for the drop-down menu. You can always come back to this. Again, there is declaration of workbook, declaration of worksheet, basic, so that your programming will not be that too long. It's important. Not required actually ang declaration of workbook and worksheet. This is not required always. But then in order for you to shorten your programming, there is a necessity of having it declared. Okay? So WS estimate is for your estimate worksheet. Specs is your specs worksheet. Okay? We are going to have a dia X and dia Y, or diameter for combo box. Combo box diameter of the combo box for the diameter of rebars. Okay? If you notice, your WS, which is specs, WS size rather, WS is size worksheet. If you notice, we encoded there the rebars, okay, and the diameter of rebars. We are just calling it from this block of code. So do until the section or the cell is empty, ws.cells I1, take note, declared I also here, the value. Cells I1 represents a cell at row number I and column number 1. Okay? If the code sees rebars, then it is going to perform this. diameter X item, and then adding the diameter in your combo box. Okay, so this is it. This is just adding the combo box drop down. So diameter X at item, diameter X item. This is adding diameter Y at diameter X, diameter of rebars along X. Dia Y is diameter of rebars along Y. So adding drop down menu. Likewise, this is also happening in the specs, the same procedure that we are having, but then we are utilizing here the specs. We are utilizing the specs sheet. Take note that we declared specs worksheet in here, WS_specs. So from there, we get the information and then we display it in the combo box. Add items, specs items. Okay. So this is now running the user form from the VBA environment. You can run the user form using this button. Simple, huh? This button, just like a triangle or play button, we can play it from here so that your trial will not be coming from anywhere else. You can do the trial if your user form or macro, any macro or any code will run without error. So this is some part of the debugging process. Play, you can have pause also or stop. So to run it, just click display button, play, and it will be displayed just like this one. So you have to test if your drop-down menu for your combo boxes are working. So test, okay, so we have tested already that 3 bars along X has complete information for the diameter of bars, and likewise all the rest, number of rebars along diameter of rebars along Y, concrete strength, and rebars grade shall be tested also. Okay, so we don't have the calculations yet. This is still the testing if your drop-down menu is working. Okay, after testing, we're going to code also the command button calculate and clear. This is for your calculator. The calculate and clear button, if you go back, this calculate and this clear button, okay, the code is very simple. So the first one is for your calculate button. Take note that when you code it, actually when you click the button, this will automatically generate private sub calculate underscore click. The underscore click will identify that these codes will be run when you click the button. Okay, underscore click. The calculate is the name of your button. Okay, underscore click. That means that you have to click in order for you to run the code. Okay, so same declaration of the workbook and worksheet. Now, what's happening in here is that I have a hidden cell at row number 1, column number 1000. The column number 1000 is far at the right, so that this value will not be within my, apparently will be outside of the range of my worksheet, of where I am working at. So 1000, I am hiding some formula. Equals calc that value. Okay, calc that value is the value of your user form input named calc. Okay, This one is the calc. If you can still remember. This one is ANS. So when you calculate, the value of that calc will be displayed in the cells 1, row number 1, column number 1000. Then the answer will be WS equals cells 1. Whatever will come out here is the answer. So this is somehow a cheat. We are hiding the cell so that it will not be actually displayed, but then we are displaying the values back to your worksheet, to your user form. So the ANS value will be displayed here. Okay. Likewise, click clear, click. So if you go back, this one is the clear button. If you press this, these two will be cleared. So very simple, calc value equals blank, ANS value equals blank. So the user form input calc and ANS will be cleared. So very simple ang code for the calculator. Codes for command button estimate override. This is where the action takes place. The command button estimate override. We're going to go back to the form. This one, estimate override. When you click this, those codes will be executed. So basic, the declaration of the worksheet, we're going to declare the worksheet as the estimate worksheet. Then we're going to run the clear estimate macro. Remember previously that we created the clear estimate macro. This is where we're going to run it also. We declare the variables. So all the variables that you will be needing, n value, x val, y val, this indicates value, val indicates value, but then you can name it, you can declare it, whatever variable you want. Variable could be in combination of letters, small or big letters, combination of letters and numbers. You can do it. You can have the declaration. Okay? So all this declaration will be used in the calculation. These are just like variables in our calculation sa may manual calculation. Variables. We are going to assign next values to those variables. So after declaring those variables, assign values to those variables. Where should the values come from? These values shall come from the inputs that we are having. So number of footings, n val. Length dimension along x direction, x val. So that is taken from the user form input x, named x. Okay? So that is why I said earlier that we have to name it properly and that we can identify those names. Y val is y value, z val is z value. Diameter x val is diameter x dot value. Diameter x again, diameter of bars along x, diameter of bars along y, diameter of bars along x, the number of bars along x, number of bars along y. So all those, including the specs for your concrete, the strength of your concrete, the spec for your rebar, this is the grades of your rebars from drop down, factors that we are going to have in the calculation. So all those shall be assigned. Okay. So after assigning all the values to variables, we're going to have the calculation. Okay, this is where we're going to calculate the concrete volume. So we declared earlier the conc volume to be the volume of concrete. Take note, calculation. N val, x val. N is number of footings. X is the dimension along x. Y val is dimension along y. Z val is the thickness. Multiply it by the factor, volume factor for concrete, and all these values are in millimeters. That is why I divided it with 1 million, so that the result will be in cubic meter. Okay. We need to have some calculation because the values result here will be displayed later on. Okay. Lean concrete. So assuming that we have in my projects, especially in Saudi, this is very common. There is lean concrete before you construct a footing. Okay, this is used for the accuracy in the positioning of your formworks and positioning of your rebars. Unlike here in locally that we just have it gravel field, compact maybe, and then position your rebars over the gravel. The procedure actually is not that accurate, but then of course we are using that commonly. We can always revise this calculation. Instead of, say, for example, lean concrete, we can have volume of gravel base. Instead of using lean concrete, actually using base instead of lean concrete. Rebars length calculation, number of quantity of footings, number of rebars along X. Okay, but then this length along X shall be subtracted by the covering. We usually subtract a length of 75 mm or 0.075 meter. This is in the case of straight bars, because there might have some case that your rebars will be bent whenever the development length is not enough. You have to bend it at the side. Okay, this assumption is that the development length is actually enough for our rebars. So let's make it straight bar only. So the rebar length calculation, of course, factor, and this will be having a result of number of meters of rebars. Likewise for rebar length along Y direction calculation. Tie wire. Okay, I'm assuming here that every tie wire is having a length of 0.4 meter. So number of footing times length of every tie wire, number of rebars along X and number of rebars along Y. So I'm counting the number of intersections. Okay, number of intersections. Every intersection will be tied by 0.4 length, and we have to divide all of this by 53 kilograms per, I think 53 kilograms per, 53 meters per kilogram rather. 53 meters per kilogram of tie wire with a gauge 16. I think this is standard. Okay. If you need formwork in the sides of your footing, this is the calculation also. So this is just actually perimeter, total perimeter multiplied by depth. Perimeter of your footing multiplied by depth. If you don't need this, okay, if you don't need the formwork, so just a hole, and then the formwork will be the sides of the excavation. Delete it in the result. You can always delete something. Much better you delete rather than you create or you calculate. Okay, so this is in the case that you are using formwork, so that you can calculate the total area of formwork in relation to the cost of formwork. Okay, so that's it for the calculation. Very short. Then after you calculate, you don't just calculate, you have to display the result. Okay, so this is important. Display the result in your worksheet. So in your worksheet, at row number 10, if we can, we do have, we don't have the worksheet here. Okay, at row number 10, sales 10, row number 10, column number 2, we're going to display isolated footing. At row number 11, column number 2, we're going to display concrete mix plus what is the specs for your concrete, 5,000 PSI, 3,000 PSI. So this is the value from the variable that we are displaying. WS cells, row number 11, column number 4, concrete volume. Column number 5, cubic meters. Okay, so this for the conc volume that we have calculated previously. Take note, this is the conc volume, okay, in our calculation. We are just displaying it in our worksheet. Okay. At row number 12, the calculation and display of our rebars. Display of our rebar, bar diameter. This is text, whenever you enclose it in the what do you call that? Then this is the diameter of bars along X direction. So this is rebar, say 16 mm diameter, grade 40. So displaying total length is rebar length along X plus rebar length along Y. So just sum up. Then display at row number 4, row number 12, column number 4, the rebar total length. Then display at column number 5 the quantity in the meters, M, unit. So this is all about displaying in the worksheet. Yan. Row number 13, tie wire. At column number 2, row 13, see cells, quantity, first value is row number, second value is column number. GI tie wire, gauge 16. Column number 4, tie wire in kilograms. This is the result of our calculation for tie wire kilogram. Row number 5, column number 5 is the unit, kilograms. This same thing will happen in the row number 14 for concrete volume, and for row number 15, the area of formworks, displaying values. Then we run the macro named costing. The costing macro, because this costing macro has its own set of codes that will collect the information of every material, costing of every material that you are using in your estimate. This is the costing macro. And every sub shall be end with end sub. Yeah. So that was the code for estimate override. Ang estimate append is also similar with estimate override. Okay, so I'm not going to explain in detail because all these are just copied from estimate override. The only difference, so ang the declaration of sheets, by the way, private sub, declaration of the sheets, declaration of the variables, the same. The value variable assignment, the same as with estimate override. The only thing, even the calculation, the same, but you have to copy it and paste so that everything will be run in one set of codes. The only thing that is different from estimate append from estimate override is the addition. Take note of this. This is the plus conc volume. Okay, so the original value of your concrete volume already within the cell is being added by the new value that we calculated. That is why we call it append. Okay? We call it append. That same display for other values, the same, the same. Likewise, for the rebars, the original value in that cell is being added by the new value that we calculated here in the append. Okay? Also in the tie wire, the original value will be added by tie wire kilograms, the new calculated value, append. Concrete volume, append. Formwork area, append. So add. So that you will no longer have manual calculation when you have another set of footings. Just like you have 10 pieces of 10 units of footing 1, F1, 15 units of F2. So you don't need to calculate adding manually the values for F1 and F2. Just have to append. Then again, run the macro named costing. This is just calling the macro. Call the macro to run. Costing. The name of the macro is costing. Then every sub shall be ended with end sub. Okay. What's this? The costing macro. This is the costing macro that I was talking about. This is somehow complicated in nature because when I say complicated because of the loops. Okay. If you see the clear estimate, this is the existing macro that we just ran. This set is for declaration of your worksheet and workbook only. This one is for from here to here. This is how we generate information from the materials database. Take note that we have created the material sheet for the material database with corresponding costing. And we are getting that information to be transferred here in our estimate worksheet. We are automating the costing itself. Whenever our program identifies that there is, say, for example, 16 mm diameter rebars gauge grade 40, from the estimate, it will get the information of that specific material from the materials database. This is how this code runs. Okay? This might be complicated, but you can always go back and study how it is being generated. There are 2 for loops. One loop is for I 11 to 25. It ended with next I here. And the other for loop is for I equals J to 1001. Materials is only up to row 1000. Considering materials is only up to row 1000, if you have more than 1000, you can change this, the value 1001 to maybe 10,000. And if it will identify that the value in the materials is the same as the material in the estimate section, estimate sheet, it will run this code. That's it. It will run that code. So displaying the information of your costing from column number 6, 7, 8, 9, and 10 will get the information from there. It will display the information here coming from the materials. This one, from the materials. Okay? This will be very deep, actually. But then you have the code, you can copy that. Okay, so that is for the costing automation. Now, let us do the debugging and testing. I'm going to share the actual estimate screen. How do we debug? If your code has some bugs, for example, we're going to run this. If you run that, from so I'm going to close this first. If you run this without any error, okay, so and then estimate override, you can have also estimate append, you can have 10 times 20, calculate, good as 200. That means that you are bug free already. But then let me try to have some bug. I'm going to create some bug in here. Say for example, from your estimate override, you declare clear estimate from here. But then, actually, there is no clear estimate code.
Hello, engineer. Sorry. Excuse
Oh.
po, engineer. Sorry
Yes,
to
ma'am.
interrupt again. Nag-stop sir yung share screen.
Ay, sorry. What is that? Again, is it now viewed?
We
Excel
can now
file.
see it, engineer.
Okay.
Thank you.
I'm going to repeat that. Okay. I am running the code from here. Run sub user form. Okay. I'm going to run this user form as displayed from here. And if you try, say, for example, 10 times 3, calculate, there is no bug. Clear, there's no bug. There is a bug when when some error will appear. Then estimate append, estimate override, estimate append. There is no bug. Well, we are trying to debug. But say, for example, I'm going to granting that I forgot to create this set of code, the clear estimate code. Granting that I forgot. And I'm running this. Take note that from here, we run this clear estimate. Okay, from estimate override button, we run the clear estimate. But then the clear estimate is not actually within. So if I'm going to run, there is a compiler error, sub or function not defined. So this is already what we call as bug. Okay, you declare the function or the sub, but then it is not actually available. Okay, so we can debug that, clear estimate. We go back. Take note that when you create an apostrophe, you are, what do you call that? You are actually commenting. Create some comment. That comment, the green one, is not actually a running code. It is a comment. So I just uncomment that. Okay. So that means that this sub clear estimate is already available. I save that. I'm going to go back to the forms and then run this form. So you will see that there's no bug anymore. So this is debugging procedure. Whenever you see an error or whenever you see, say for example, 1000 by 1000 overwrite 500, we're going to try if the values are correct, of course. Concrete factor is 1, estimate override. So you see that concrete mix is 1 meter by 1 meter by 1 meter by 0.5 meter is actually having a volume of 0.5 cubic meter. So this is testing if the values that are being displayed, that are being calculated is accurate or not. Okay? Likewise, you can test also the, let's have a factor of 1. If somehow the rebars is okay, estimate override, is it 20.4? You can calculate. For say 10 pieces, override, is it 17 meters total length? If you have 1 meter by 1 meter width, dimension of footing, is it okay? You can do the manual calculation first and validate. Always validate the result. Okay, always validate the result. Okay, just a few moments more, then we're through. I'm going to transfer my screen to the presentation. Where is it? Now, how do I create a macro to show the isolated footing form user form? Isolated footing user form. In the module 1, in the modules section, we have to declare something that will show our isolated footing macro. The forms isolated footing shall be displayed. Are you viewing my screen? Yes?
Yes, sir.
Okay, thank you. The form isolated footing shall be automatically displayed in a single click button. We have to create that shortcut button using module. Okay? So module macro, isolated footing underscore show. This is just the name. You can name it the way you want, but this has to be precise. Isolated footing that show. The isolated footing is actually the name of the form. Isolated footing. Isolated footing that show. Okay? So we create that from the module, from the module. Then we create a text box, or it could be a button. You can insert a shape. You can insert a text box, whatever. And right click on that. In my case here, I inserted a text box. And then right click and then click assign macro. Okay. So I assigned the recently made macro named isolated footing show. Okay. And then press OK. And then I am through with my program. Okay. So this is now the final VBA program. I'm going to show it also in actual Excel. So I have one user form, isolated footing. I have module 1 where I created the clear estimate cost, costing macro, and I also added the auto summary and spell currency. The spell currency, I will explain this one also. You create a word out of a currency. So I made use of this in the summary. And this is the working macro program. Okay. I'm going to share how did it happen in the Excel worksheet. It's my Excel worksheet. Share. Okay. So this is the final testing of our program. Are you viewing the Excel sheet? Yes.
Yes, sir.
Okay. So when I click footing, this is it. When I click footing. So again, we're going to try. So say for example, we have 15 to 1,800 by 1,800. The thickness is 400, 16 mm diameter, 11 pieces, 3,000 PSI. I'm going to change this to 3,500 PSI. The grade 60, I'm going to change this. This drop down. Grade 40, estimate override. Okay. Then I'm going to add footing 2. For example, 20, 1,500 by 1,500. Thickness is 350. Take note that it shall be the same, the diameter pa, so that you will have to append. If you are going to append, maintain it has to be the same diameter. Okay? Because it will append to the same diameter 16. 4,500 PSI. So the same values, I'm going to click append and notice what will happen. Append. Okay. So values are being added. Are you viewing the form? Isolated footing form, this one? Yes?
Yes, sir. Yes, po.
Thank you. How much time left for me?
Four minutes left, engineer.
Okay. So it will be a good timing. I'm going to share an actual procedure for estimate, actual plan. How do I share another? Where is it? This one. Okay. So say for example, we have this. You are going to estimate all the footings. Only isolated footing. So we have F1, 2 pieces. F2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 pieces F1, 10 pieces F2. And F3 is 2 pieces. Okay? And then for the schedule, F1 is 1,800. Tandaan nyo 2 pieces F1, 10 pieces F2, 2 pieces F3. So 2, 10, 2. Okay. F1 is 1,800 by 1,800, 300 mm thickness, 10 pieces, 16 mm diameter. F2 and F2 prime, the same lang ni sa dimension, 1,600 by 1,600 by 300, 9 pieces, 16 mm diameter. F3, 1,3 by 1,3, 300 mm thickness, 8 pieces, 16 mm diameter. So let's see how fast we can do the estimate out of this. So please have it in your memory. I'm going to share again that Excel. Excel. Okay, share. Estimate. Footing. Okay, number of units for F1. 2 units. 1,800 by 1,800. Thickness is 300. 10 pieces, right? 6 mm diameter along Y and along X. Strength, we call it, we make use of say 3,000 PSI, but the steel is grade 40. We're going to make use a factor of safety of 10% additional. So 1.1. For a bar divot, 1.1 also, additional 10%. So we press estimate override. Okay, so we have the value for your 2 pieces F1. Okay, for F2, 10 units, 1,600 by 1,600, 300, 16 mm diameter, 9 pieces, 16 mm diameter. So the same in Y direction, 3,000 PSI, grade 40, concrete factor is 1.1, rebar factor is 1.1, additional of 10%. Estimate append this time. Estimate append. So notice what will happen in the quantity and of course in the costing also. So estimate append. Yan. So we have actually added this new footing. Lastly, we have footing 3, 2 units, 1,300 by 1,300, 300 mm thickness, then 8 pieces, 16 mm diameter, 3,000 PSI, grade 40, 1.1 and 1.1 for the factor. Estimate append. Okay, so I'm going to close this. I now have all the quantities for my isolated footing. So what I'm going to do is to copy this, go into my BOM detail. Okay, and then where is my foundation? Okay, I'm going to paste this here. There's my paste. Okay, so this is now the, take note, the estimate and the BOM detail shall have similar format para ma-paste mo. You cannot paste it here if they do have different format. So that is why I formatted this estimate sheet the same as the similar as the format of my original BOM detail. Okay? Okay, so I have here the values now. And the last thing that I'm going to do is to update this the summary. You can delete the information and delete all the information also. Originally, I have 17,217 million. So I'm going to delete this. I'm going to click auto generate summary and boom, everything is being updated. And now I have different cost. Okay, so that is how fast you can do the calculation, the estimate of your the whole of your footing in maybe a couple of minutes, 1 minute maybe, by utilizing the automation. Okay. Again, for example, I only have here what happens in the in our costing macro. I also added a costing macro here so that this one are actually the cost are actually generated out of these materials here coming from the material sheet. It's just coming from here. I have a material database. Okay. So that is why when the footing is being run, that costing macro is also run at the same time. Estimate of the right. Actually, that same costing macro was run. If you delete this, costing. Okay. This clear macro, just clear the sheet. Okay. Okay. So I hope that you have learned something from this and you are interested in this topic. I'm going to go back to my main slide. Thank you for your attention. So if you have some questions, so that is how we automate things. So again, this is working on how we simplify and how we make things easier and yet very efficient and accurate. Okay? So much better if you do your own. If you cannot really do this, have somebody do it for you. Okay, so thank you for your attention once again. Miss Moderator Anika, right?
Yes, sir. Okay, thank you so much, Engineer Felemuel Bullos for Junior for sharing a wonderful topic, no, entitled Estimating Automation Using Excel VBA Macro Programming. And I believe most of our participants find your presentation very helpful, again, Engineer. So thank you. Madam, ingat salamat once again. Okay, so this moment once again is now open for Q&A. I'd like to request everyone to turn on once again their cameras for this session for the recording purposes or for documentation purposes. And please key in your questions for Engineer Bullios now if you have something to clarify or ask him. So I can read it and will ask Engineer some answers. Sige. So far, wala pa pong questions. Sige, participants, please key in na your questions on our chat box. And while you are thinking about your questions, we will be sending again the last evaluation form on your mobile numbers and even sa emails. We have one new message and it comes from so the participants are asking for the Excel for the PowerPoint presentation. So for that, we will be converting all the presentations of all speakers for this webinar. No, we will convert it to PDF file and we will put them on a Google Drive and we will share it to all of you after the event. Okay, so may nakita na akong question from I believe from Sir Christian. The question is the same programming when analyzing structural designs? Yun, Engineer Bullios.
Yes, we can do also the same programming actually in the structural analysis and design. And I am actually using the same macro programming in the structural analysis. And it's quite fast, automated. The calculation itself is, of course, we already know the knowledge of the calculation. We already know in the same case that we know the estimate itself. But then what we do in here is just automating the process so that we can have our work very fast, very efficient, and very accurate.
Okay, so any more questions? we still have we have 10 minutes for Q&A. So the participants are expressing their gratitude. Marami damo giga comments sa chat box ngayon. Thank you so much, engineer.
I know that there is not much of the question because there is no question, just two case. Either you know everything or you know nothing.
Ayun, sir, may question from Engineer Mark Zed. Hi, is there a way it can show what footings are included in the quantity in case there's too many number of footings?
If you want to show the calculation itself, you can have it coded. But then in my case, because I'm already what they call that, I'm already confident of my program, I don't use already the I don't show already the calculation. I'm already confident with my program. Unless you have a boss who's going to check your work, then you have to code it yourself and show the calculation. But then if there is no boss, you are the boss of your own, there is no need of showing the calculation if you are already confident that your program is accurate. Yes. More questions?
I believe going once. Okay. Ito may-ari pa. Hingagaw, si Engineer Estacio. Sir, are you selling these programs? How much is the cost for the structural analysis and design? Good question.
Wow, good question. Cost. I'm going to show you my personal program. Okay, I'm going to share some screen. My personal program used in estimating. Where is it? Moment. I'm opening some. Share screen. This is my personal program. Actually, I just started this doing this just a month ago because I just came from Saudi Arabia and I did not have time to revisit my programmings. Okay. Are you viewing my screen? I already have a bunch of macro programs in this. So instead of we discuss only footing, I already have a footing, just like similar to that one. Wall footing, beams, columns, slab on fill, steel deck slab, one-way slab, two-way slab, wall, stairs. So say for example, I'm going to have beam. So for the beams, you need to input, say, total length of the beam. So say for example, the total length is 5 pieces, 5 meters span. Let's call it 5 meters, 10 units of 5 meters span. So the total length is 50. Say 200 by 600. Then in one cross section at the support, there are 6 on top and 4 at the bottom. Just like an example, so 10 pieces, at rebars at midspan. So there are, say, 4 bottom, 2 top, 6. Then stirrups, 10 mm diameter, 5. I'm going to have 10 at 100, rest at 200. Then I'm going to change 4,000 PSI, grade 60 steel, then estimate override. See? If I have, say, another set of beams, by the way, this is 10 spans. 10 spans. Because you have to count the number of spans because of this spacing of stirrups. So 5 units, 5 meters, 10 spans. Change it, estimate override. And so you have the quantity. If you have 6 units of 10 meter span, same value, you can have estimate append. Yan. But take note that in estimate append, you shall have the same diameter of bars here. If you have separate set of different properties of beam, then you should not go into estimate append. You have to do another set. So you have to close this and then copy this in your beams. Copy, BOM detail, and say okay, columns, beams, paste it here. Okay. What's good in this? I also have item summary. So say for example, I have 16 mm diameter grade 60. I can count the number of 16 mm diameter grade 60 in my whole estimate. So from here, I'm just going to select this row. Okay, or select that item summary. If you notice, I have only 365 meters here, but the total for my whole project for 16 mm diameter, I'm going to purchase 1,333 meters. If you're purchasing 6 meters, so divide that by 6. I also have the total cost of all 16 mm diameter grade 60. This is the beauty of the beauty of automation. What is the procedure on calculating the total amount of the total quantity of, say, 10 mm diameter rebars or tie wires? 10 mm diameter. Provided that they have the same specs. So select that item summary. This is now the total, 2,290. And of course, it also have automate generate summary and everything. Even if you did it, if you are just only having 15 or 17, for example, we only have 15 sections. Generate summary, it will just generate summary for 15 sections, whatever you listed here. Okay. But for the question of how much, for now, I could not really send out this unless you have the intention of buying. I have also actually the intention of developing, full development, because this one, I use this for my personal consumption for the moment. But my company, the FTB Smart Solutions, actually intending to develop some softwares and sell that out for a very minimal cost. I'm also developing, I have also a personal consumption of structural calculations, and I have also the intention, but not now, not yet. If you have the intention of say acquiring one from me, then you can message me in Facebook or you can email me, so that I can, if I have, say for example, 100 intentions, then I'm going to speed up the process of developing and share it to everybody.